going to take a look at using two-way tables or frequency tables in order to calculate probabilities. So given here to the right is a two-way table with test results for a group of students in a college pre-calculus course. This, of course, is made up. This is not actual data from any of our courses here. So first one, if you look at one student's grade at random, what is the probability that the student is female and got a B on the test? Okay, so let's take a look up here at the table. Here's our female column. Here's our B column, or excuse me, female row, B column. So what's the probability that the student is a female and got a B on the test? So right here are the number of females who got a B on the test, right? So our top number is going to be 19, and we're looking at one student's grade at random. So the total number of students is 88. Okay, so we are looking at 19 out of 88. Okay, so we're looking at the probability that a student was a female and got a B. So 19 out of 88. Okay, let's now, again, I don't know what form you might have to put the answer, so we'll just put them all down. So 19 divided by 88 is 0.21591. So that would be 21.591%. Okay. And again, don't know what form you may have to put your answers. So those are the different ways that we could express these answers as far as the probability. We could give a fraction, we could give a decimal, or we could give the percent. All right. Part B. If you look at one student's grade at random, again, we're just picking one student grade at random. What is the probability that the student is male and got an A on the test? Okay, so let's go back up. Male is this row, and A on the test. Okay, so we're looking at 15 students were males who got an A on the test, and we still have 88 total. So this one is 15 out of 88. Okay, we're going to do the same thing again. We're going to get the decimal. So we're talking about 0.17045, or that could be 17.045%. Okay, all three of those would be acceptable answers. It really just depends on what they're asking for the question. Okay, a lot of times they'll give you, if it's multiple choice, obviously you'll take a look at the answer choices and see how they have formatted the answer choices, or if it is a free response or fill in the blank, they'll tell you how to format your answer. All right, let's try another one. Let's take a look at this table. Two-way table below shows the results when kids and adults were asked whether they preferred pizza or burgers. Okay, what percentage of all who were polled prefer pizza? Okay, this time we're asking for percent. Okay, so let's take a look. One nice thing that we're going to love about this is that the total number of people is 100, so that makes percents very easy to find, right? So then what percentage of all who were polled, so we are talking about the total number, so this is going to be out of 100, okay, prefer pizza. Okay, so total number of pizza is 39. 39 out of 100 is 39%. Okay, again, we really like when it's out of 100 because that makes it a lot easier. Okay, let's go. Well, I didn't mean to go all the way down there. Can we have a happy medium here? Maybe not. Okay. Part B, what percentage of all who were polled were adults who prefer burgers? Okay, so this one is still out of all who were polled, so it's still out of 100, but this is a lot more specific. This says adults who preferred burgers. Okay, so let's look at the adults row and the burgers column. So there are 26 adults who prefer burgers. So that is a percentage, 26%. Oops, there we go. Okay, one more. What percentage of those who preferred burgers were kids? Okay, so now this one's a little bit different. Notice that this doesn't say percentage of all who were polled. This says what percentage of those who preferred burgers. So let's go take a look. How many people preferred burgers? That was 61 people, right? 61 people preferred burgers. So that's our bottom number this time. Okay, it's not out of 100, it's out of 61 because it said what percentage of those who preferred burgers, okay, were kids. So let's go take a look. The kids that preferred burgers, 35. Okay, so our top number is 35. Those were the kids that preferred burgers. Now we're going to need to divide. Okay, so we're going to take 35 and divide by 61. Okay, we want to get the percentage, so we're going to move the decimal over 2 places. So that would give us 57.377%. Okay. Again, we're still just moving through possibility. The total number of what you want to occur divided by the total possibilities. All right, so here's one that's a little bit different. Two-way table for 9th graders transportation to school is shown. Complete the two-way table by finding the missing information. So this one doesn't have everything here. So we're going to have to do a little bit of work. Maybe the easiest place to start is with the total. So on the bottom, notice that we have 129 and 92 for the totals of males. Excuse me, total of males and females. That would be 221 total people. Now we've got 3 of the blocks out of 4 for the total on the right hand column. So let's take all of those away from 221. Okay, so 221 minus 69 minus 27 minus 45. So that leaves 80. Now let's start taking a look from left to right. If there's a total of 80 that wanted to walk and 46 were female, we can take that away from 80 and get the number of males who wanted to walk, which was 34. Okay. Cars, the total is 45. 28 were males, so let's subtract 28 from 45 to get the females. That would be 17. Bus was 27. 12 were female. If we subtract that away, that's 15 for the males. Bikes, that was 69. If we take 17 away, that leaves 52 for the males. We could also add up our totals in the columns now and just make sure that those add up correctly and make sense. So if we add 34, 28, 15, and 52, that should give us 129. And if we add over here in the female column, 46 plus 17 plus 12 plus 17, that should give us 92, which it does. Good. Okay, so now we did part A. We completed the table. Now we're taking a look at some questions based on this table. What percentage of 9th grade girls walk to school? Okay, so all of these are 9th graders, so it doesn't matter that they said 9th grade. But what percentage of the 9th grade girls walk to school? So take a look. We're percentage of 9th grade girls. So 9th grade girls is what we're starting with. There were 92 females. So 92 is our bottom number, right? Now, we got to figure out how many of them walked to school. That was 46. Okay, so 46 out of 92, which is, it said what percentage? So that is 50%. That's half. Okay, so half of 9th grade girls walk to school. Part C, what percentage of 9th graders? So that's all the 9th graders. That's 221 is our bottom number. What percentage of 9th graders are girls who walk to school? Okay, we already know that number. That top number is still 46, the females that walk to school. Okay, if we divide now, we want the percentage. Okay, remember we're just getting the percentage because that's what it asks for. So if we do 46 divided by 221, that's going to give us 20.814%. Okay. Part D, what percentage of 9th graders are boys who take the bus? Okay, so it's still asking percentage of 9th graders, so that bottom number is still 221. Okay, top number needs to be the boys who take the bus. So let's take a look. If I can go back up. Males who take the bus is 15. Okay, so our top number here is 15. If we take 15 divided by 221, we want the percentage, so that would be 6.787%. Okay, so 6.787%. Now, last one. What percentage of 9th graders do not walk to school? Okay, so 221 is still our bottom number because it says what percentage of 9th graders. And then it says do not walk to school. Okay, so let's go up and take a look. Now, there's a couple of things we could do. We can either add up all three of these columns or blocks. Okay, we can add up the totals there for car, bus, and bike, or we could simply take away the number that walk from the total. Okay, 80 people walk, so if we take 221 and we subtract 80, that would be all our non-walkers left. So if we subtract 80 away, that leaves 141. And again, you can add up the others. You could add up, what was it, the car, the bus, and the bike. Add up those three numbers, you'll get the same thing. So we have 141 out of 221. Let's get that decimal for the percentage. So that would be 63.801%. Okay, so a large percentage do not walk to school. Okay, all right. That one was a little bit different because we had to fill in some information. And then we started finding our percentages. Guys, I do want to make sure to point out that you need to be very careful about paying attention to the wording of the problem. Take a look at B and C. Those are really similar questions, but they have very different answers. Because part B said what percentage of ninth grade girls, and then part C said what percentage of ninth graders are girls. Both of them had to do with girls walking to school, but they had different bottom numbers based on the way they asked the question. So just be careful about that. Make sure you pay close attention. Okay, next one. Group of people was surveyed about their favorite movie genre. The participants had to give their age and choose their favorite genre from action, comedy, and horror. Results are given in the two-way table below. The only thing they don't have is the totals, so let's quickly add those up. If we add up the action column, we get a total of 908. If we add up the comedy totals, we got three different ones. We want to add these up, we'd get 1412. If we add up the horror comedies, if we add up the horror column, these three numbers, we should get 680. And then, of course, our total numbers, that should be easy from the column over here. 1,000 three different times should give us 3,000 total. So there's 3,000 people total that were surveyed. Okay, so now let's start trying to answer some questions. Okay, a company that sells a product designed for young adults is looking to advertise before the movies of one of these genres. Which should they choose and why? Okay, so what I would take a look at is we're talking about young adults. So those would be the ones that are just newly adults. That'd be 18 to 25-year-olds. So we're looking at this row here. Which of those rows, those blocks in the row, have the highest number of people? Well, that would be under comedy. We've got 450, right? So that's the highest percentage of favorites is under comedy. So that's why we want to pick comedy for where they would advertise. And then as a reason why, it's the highest percentage of favorites among 18 to 25-year-olds. Okay. Part B, let's see if I can move this. Oh, and I can. Okay, part B, if you surveyed 12,000 people total, how many 18 to 25-year-olds would you expect to choose horror as their favorite genre? Okay, so let's, first of all, we're still looking at the 18 to 25 category. We have out of 3,000 people, we have 18 to 25-year-olds for horror is 312. Right? So we can take that percentage and we can multiply it by 12,000 to find how many we would expect to be the same out of 12,000 people. Okay, so we're basically taking the fraction of 3,000 people and multiplying it by 12,000. You could also set up a proportion and it would end up doing the same thing. So if we take 312 divided by 3,000 and multiply by 12,000, that's going to give us 1,248 people. Okay, so 1,248 we could expect to have the same favorite. Part C, if you surveyed 24,000 people total, how many 25 to 49-year-olds would you expect to choose comedy as their favorite? Okay, so let's take a look here. Now we're looking in the 25 to 49-year-olds, so that's that second row here. Comedy is 472. Okay, so 472 out of our total 3,000, and they're going to survey 24,000 people. So let's multiply 472 divided by 3,000 times 24,000, and that's going to give us 3,776 people. Okay, that's how many we could expect to be 25 to 49-year-olds that choose comedy. All right, let's take a look at question D. We'll go back up if we need to for the survey. What percentage of the 50-plus-year-olds did not prefer action as their favorite genre? All right, so we want to look up at the percentage of 50-plus-year-olds that did not prefer action. So let's go up and take a look. We're looking at this third row now. 320 preferred action, so I'm just going to take that away. You could also just add the other two, 490 plus 190 for the other two columns. So if we take 320 away, that would leave 680 out of the 1,000 50-plus-year-olds. So those are the ones who did not prefer action. Okay, so if we divide that, that's an easy one to get the percentage. That's going to be 68%. Okay, so 68% did not, of the 50-plus-year-olds did not prefer action. Okay. All right. Now we're taking a look here. Semester grades from a freshman English course are given in the two-way table below. What's the probability that a randomly selected student got an A or a B? Okay, so here's the thing to think about. This is an OR equation, but notice it says A or a B. Can we have a grade that's an A and a B? No. So this one's mutually exclusive, which is nice. We don't have to subtract anything away. So probability that a randomly selected student, so that's out of the total, okay, that's out of 100, got an A or a B, okay, and that's 20 and 15 people, so that's 35 people total got an A or a B, which would be 0.35 or 35%, depending on what they're looking for. Part B, what is the probability that an A student is male? Okay, so an A student is what we're starting with, and there are a total of 20 A students, right? Probability that an A student is male. So of those 20, 12 were males. Okay, we could reduce that fraction if we need to. Divide by 4, and that's 3 out of 5. Okay, so as a decimal, that's 0.6. As a percent, that's 60%. Okay, now moving on. Next, probability that a passing student was female. Okay, so there's 100 students. There's only 13 total that are failing, right? F is failing. So there's only 13 that are failing. So that means there are, take that away from 100, that's 87 students that are passing. So that's our bottom number. Probability that a passing student was female. Okay. How many females are failing? We're going to take that away. So there's 44 females, 6 of them were failing. So if I take 6 away from 44, that's going to leave 38 females that were passing. Okay, so a lot of this is kind of knowing where you can subtract and just make it a little bit easier on yourself. Rather than having to add up all the females that had an A, B, C, or D, I can just take the F away from the total females. Okay, so 38 out of 87. Now that was an even one. So 38 divided by 87. As a decimal, that's 0.43. Let's see, 678. Or that's 43.678%. Part D, what's the probability that if a student is male that he earned an F? Okay, so we're only looking at the male students this time. Okay, there were 56 male students, so that's our bottom number. That's our number that we're pulling from, that he earned an F. There are 7 of those, so 7 out of 56, okay, which is 1/8 if we reduce. They're both divisible by 7, so that's 1/8 if we need to reduce it. Okay, so if we divide, that's 0.125 or, excuse me, 12.5%. Okay, last one. What is the probability of randomly selecting a male or female student who earned a C? Okay, so we're going to randomly select. This is out of the 100, right? Okay, so out of the 100 random students, what is the probability of selecting a male or female student? Now, male or female, they can't be both, so they can't have both in that row. We have those rows separated, so that's nice. Now, if we're talking about C, there's no and where they join. It's just 17 and 13. So if we add those together, that's a total of 30. 17 plus 13 is 30. That would reduce to be 3 out of 10 or 30%. Okay. All right, last example. We're using a frequency table showing results after teenage males were asked their gaming preference of Mario or Zelda, and then a sport preference of running, football, baseball, or soccer. Okay, so first one, we want to find the probability of Z. So we're looking at Zelda. The probability that they picked Zelda, that was 77 out of 159 total. Okay, I'm just going to go ahead and write the percent so that because we're going to run out of space. So 77 out of 159 would be 48.428%. Okay, let's try B, probability of what? M and F, so Mario and football. So let's find that. Mario and football, that's 22 people. Excuse me, 22 out of the 9 total. Okay, so if we take 22 and we divide 159, that gives us, as a percentage, 13.836%. Okay, let's keep going. C, probability of M or Z. Okay, so we need to figure out, are they mutually exclusive? We'll take a look. M or Z, they can't have any that are both of those, right? Those are broken up into 2 different rows. There's nowhere where they intersect in the table. Okay, so we don't have to worry about subtracting anything. So M or Z is everything, right? Okay, that's 159 out of 159. They had to pick one or the other. So that's 1 or 100%. Okay, probability of F or S. So that's football or soccer. Okay, so those don't intersect at all on the table. So those are mutually exclusive. So we don't have to subtract anything. So that was a total of 38 people and 30 people. So if we add those together, that's a total of 68 out of 159. So let's talk about what that percentage would be. If we had 68 divided by 159, that's going to be 42.767%. Okay, now the last 2 questions are just yes or no. Are events Z, let's see if I can, there we go, that's a little bit better. Are events Z and B mutually exclusive? So that's talking about Zelda and baseball. Are Z and B mutually exclusive? Okay, so let's take a look. Z is here, B is here. They have an intersection on the table, right? 23 people picked both of those. So no, they are not mutually exclusive. Okay, because there is an and. The and is 23 out of the 159. Part F, are events Z and M mutually exclusive? Okay, I think we actually already talked about this one. Z and M, okay, those are separate. There's nowhere on this table where somebody could pick Mario and Zelda, right? Okay, they had to pick between the two. So these are, yes, mutually exclusive. There's no and for those. Okay, guys, I hope you found this helpful. People tend to usually like frequency table problems because you're just using a lot of different totals. You're looking at a lot of different things. It's easy to see the numbers. Okay. You don't have to know much about the problem to begin with. You just have to look at the table to find the numbers that you need. The wording is still very important for the problems. Make sure you pay close attention to the wording so you know what they're asking you to find. But otherwise, frequency table problems should be fairly straightforward.